So now you're ready to complete your Ruby exercise for your programming assignment. And one of the first places for you to go is the resource section here. And there are two things that is maybe useful here. There's the Ruby cheat sheet, and there are a bunch of Ruby resources here that you can use to get some help. There's also remote access instructions on how to use Ruby on the Andrew Linux machines, and how to download editors like gedit to do things. There's also a Ruby reference sheet. Has a helpful reminder for the lab exams, and that can be very helpful. Now, one place you can go to is www.cmu.edu myandrew if you want to do your Ruby exercises on the Andrew servers. Now, this can be very helpful even beyond this class, that you can download the SSH client for writing your Ruby programs on Andrew machines. Now, if you download this, you will have something like this. This is my desktop, and it shows me an SSH client. So I'm going to use this to get started with my Ruby programs. So let me open that, and then I click on Quick Connect, and then I type in unix.andrew.cmu.edu and my username Guna. When I connect it, it'll ask me for the Andrew password, so I enter the Andrew password, and it got me into the Andrew machines. Now, where you are right now is your home directory. In fact, if you type in the Linux command pwd, it'll show you that I'm in my home directory called Guna. And now, one of the things I want to do is, because I'm going to be doing some Ruby exercises, I'm going to make a directory here called 15110. So I made a directory called 15110. Then I'm going to change the directory to 15110. Now, in the directory 15110, if I type ls to see all the files, I see nothing because I haven't really done anything there. So what I want to do is to develop a program, a Ruby program, and run it on this folder. So because I wanted to do edit and running on two different windows, I'm going to open up another one here, and I'm going to log in the same way. Now this time I didn't have to type in the password because the password is already typed in the previous client. This is just another instance of the same thing, but I have authenticated myself. Again, now because I'm working in the 15110, so I can show you if I type in pwd, you'll see that you're in this 15110. So here I'm going to do is to switch to 15110. In fact, I can first try pwd to see where you are at the moment. So I'm in my home directory, and then I change the directory to 15110. Okay, so this is going to be my edit window, and this is going to be my run window. So let me just start editing a file here. Now, when I'm editing the file, there are many resources you can use. One of them I'm using is a program called Emacs, but you can use gedit and any other program that you wish to edit your programs. Okay, so let me just start with Emacs, and I'm going to show you examples.ruby. Okay, so here I want to show you two examples of how to approach writing a Ruby program given the problem statement. So here we are told that you need to write a Ruby function called max to compute the maximum of two numbers, and then combine the max functions. That means use the max function to find the maximum of 4 numbers, or 5 numbers, or 6 numbers. So the thing is that once we do the max of 2 numbers, then it's going to be really powerful, or we can continue to use to compute the max of 3 numbers or 4 numbers and so on. Now, how do we start doing this? Now, I'm going to have 2 windows here, one for writing the program and one for running the program. So writing the program, I'm using a editor called Emacs, but you can use any editor you like. So let's write the max program first. So let's define a function called max. Now max takes 2 arguments, x and y. Now I have to decide. Now in Ruby, you can decide like this. These are in your lecture notes from week 3. Now the first thing I want to do is I want to decide whether if x is greater than y. If it's greater than y, then I'm going to say max is assigned x. else, if it's not, then x is less than or equal to y, then the max must be y. And the Ruby if statement ends with an n. Now notice that how I indented it. So this is the if statement. If this condition is true, we do this. Otherwise, we do this. And that's it. So this is if, and that's the end of it. And now, before you go from the function, you must return. So let's try to return the max we found. Because if you don't return, no one can use it. I don't want to print the value because I want to be able to use this function again and again and again with a different number of arguments. So let's just return max and then make sure that we have the end of the function here. So I'm going to try to save this and then go here and load the Ruby interpreter with IRB. And now I'm in the Ruby interpreter, so I'm just going to type load. My file name is examples Ruby. And if everything is okay here, it's going to show me true. So now what I need to do is to test my function. Let's say I want to find max of 2 and 3. Gives me that. Let's find max of -2 and -9. Should give me -2. Let's find the max of 0 and 10,000. Should give me 10,000. So it seems like the function is working, but I can test and test and test. I can test with very, very different type of numbers. So in all cases, it must give me the correct answer if we wrote the max function correctly here. Now the question is, how do we use this function to find the max of more than 2 numbers? Now that's an interesting question. Suppose I want to find the max of, let's say, 5, 4, and 6, and 7. But I can't use the function to find the max of 3 numbers. But what I can do is to find the max of the 4 and 6, and then find the max of that with the number 7. So this is where the return value comes really handy. Notice that how I structure this call. So the first, it's going to find the max of 4 and 6. It's going to return 6. This is why the return is important. Return means put it in a box so I can use it. Print means put it on the screen. It's done. I cannot reuse that. Now, so what happens is that it finds the max of 4 and 6. It gives me 6. And then it uses that value. So this would be 6. And then 6 and 7, that's 2 arguments still. So this gives me 1 argument, which is the return value. It compares that with the 7. So I'll get the max of 4, 6, and 7. Let's see how that works. It actually gave me the correct answer. Suppose that I want to find the max of 4 numbers. Then I could do this. Let's say I have 4 and 7, and then max of 7 and 8. Okay, so I'm trying to find the max of 4, 7, 7, 8. But I have to break them into 2 groups because I can only find the max of 2 numbers using the function I wrote. But I'm extending that function to find the max of as many numbers as I need. So there's the answer. So it seems like it's a very powerful function. I wrote the max function, I return the max, and I can take that max and put it to another function and to do more with it. Let's take a look at the second problem that we have. The second problem we have is this. Given a quadratic function, write a program to check if the graph of the equation crosses the x-axis between 0 and 10. So what that means is that if you draw this quadratic function, whatever that is, okay, and we want to know if it crosses between 0 and 10, are there any integer solutions to this equation? So what that means is if I know the function f of x, I can compute that function at 0, at 1, at 2, and so on, and then finally at 10, and see if any one of those values will be 0. Okay, so if the function crosses the x-axis, then the function value must be 0 at those points. So what I need to do is to write a function to do that. So how do we do that? So let's just assume that rather than writing this function for this particular example, I'm going to write the function in general. Ax squared plus bx plus c equals, that's my function. So how do I program that? Let's try to write a program to do this. Okay, so that's my other window. So let's go here and try to write a program. So here's my max function. here's my find zero function. So let's define a function called find zeros, and the function will take three arguments, a, b, and c. These are the coefficients of the function, and then I am testing to see if the function is going to be 0 between 0 and 10. So in order to check that for all integer values between 0 and 10, I'm going to write a loop for I in 0 to 10. So this will go through 0, 1, 2, 3 up to 10. Okay, so what I will do is to find the sum or the function value. So let's call this function value. All right, it's at that point. So how do I compute that? Well, I have the coefficient times x squared. Now keep in mind that the x is the I here. In fact, if you want to be more clear about this, you can even write x here. If for x in 0 to 10, so we can say x squared, double styles the exponential operator, then times b times x plus c. So what that does is, as you go through this function or loop, it'll plug in x equals 0, x equals 1, x equals 10, and give you a value. So what I need to do is to print this value. Okay, so I will print this values like this. I'm just going to say this something along these lines. If the value is equal to 0, if the value is equal to 0, in fact, let me do it this way. Let me print out all the values, so this is better. We can modify this later if you like. So let's just try to print this value. Now, one of the things you need to do is the value is an integer. So I need to convert that to a string, which I can do with the toString, 2s. So it's like that's a string now. And then I'm going to write a little space, or even I can write a new line here. So after it prints the first value, it'll go to the next one. So now this is going to be the end of the loop. So let's take a look at what this loop does. For each x, it runs through the loop 11 times from 0 to 10, 0, 1 through 10, 11 times, computes the value, and then print the value, convert it to a string, which is important, and then writes a new line after it prints the value. So each value will come on a new line. Okay, and here's the end of the function here. So let me try to save that, and then let me bring my window here. This is my run window. So there I'm going to load the examples again because I changed this, so I need to reload that. Okay, if it's true, it's good news. I haven't made any big mistakes here, syntactical errors, but it can still have semantics errors, which I can only find by testing it. So in order to test it, then I'm going to say find zeros. Now keep in mind that the example that we're using, it a equals 1, b equals -8, and c equals 12. So I'm going to say find zeros 1, oops, in the wrong window here, it should be here. So a is 1, b is -8, and c is 12. In other words, I'm looking at the function x squared minus 8x plus 12. Let's see what happens. Oops, gave me something here. Now, what it gave me was that it showed me the values of the function at various points of the interval. So this is the value at x equals 0, x equals 5, x equals 1, x equals 2, and so on. But now I can see that there's something here that gives me 0. But I'm not really sure what that is. Okay, in other words, I don't know for what value of x did I get the 0 for the function. In fact, I can adjust the function to print this out. So how do I do that? I'm going to go back here and say when I print the value, I'm also going to print the following. I'm going to print the value of x. Okay, so I'm going to take x and convert that to a string. Okay, and then I'm going to write a little space here. All right, so this is what this is going to do, is to print the x and the value of x. Okay, in fact, I could say something like this, even to be more descriptive. I can say x equals Okay, and then it'll print the value of x. Okay, this will print x equals as a string and then print the value of x, and then it'll print the, let me put a colon here. Okay, in fact, I should do something like this. Okay, all right, so what's happening here? Let's take a look at this again. So it prints a string. That's just print x equals something. But that something is coming, it changes every time you go through the loop. It can be 0 one time, then 1, and so on. So then you print that number here, convert it to a string, and then you probably should put a little space and some marker to separate the two things. So what we're doing is we are taking this string, which is fixed, and this string can vary because x varies, and this string, plus means just add those strings, concatenate those strings, and then it prints the value of this, that's another string, and then finally it prints the new line. All right, so let's try to save this program and then go back and load our examples. All right, what I'm going to do is, yeah, so, and then I'm going to run this program again called find zeros. All right, now I got something a little bit better. Now what it shows me is that at x equals 0, it's 12, x equals 1, it's 5, x equals 2, it's 0, and x equals 3, it's that. If I want to make it even more prettier, I could do the following. I can say colon fx equals. Okay, so what that means is, let's see what happens now. So let's go back here, load it, and then run it again. Now notice how that happens. We have x equals 0, fx equals 12, and so on. So we know that here's a point where it crosses the x-axis, or root for the quadratic equation. And here's another place here. So this concludes the short lesson on how to think about function and how to write functions.